Hello everyone, I am Dr. Ajay Kumar MV. I am the Deputy Director for Center for Operational Research in International Union Against Tuberculosis and Lung Disease. In this presentation, I am going to take you through and give you an introduction to what we are going to do in the next 2 days in data analysis. So I have titled this presentation as Efficient, Quality Assured Data Analysis Using Epidata. Now each word is important here and we will go through one by one in a short while. First, why should we do another course on data analysis? There are enough courses on data analysis already. And if you look at online, there are many online courses on data analysis. And even offline, direct face-to-face training courses, there are many on data analysis. Now, the reason why I want to focus on data analysis here is we want to introduce you to a fresh new approach to data analysis. And I want to discuss in this presentation some of the principles of that approach. The first principle in data analysis is analysis should be driven by the research question. Okay, so before you begin to use any software to do any analysis, the first thing is to ask a question. Okay, so why am I doing this analysis? What is my question? What am I trying to find out? And just do the analysis, interact with the data to get that answer. So this is a process of, talking to data step by step. And you go from simple analysis to a complex analysis. Often I find people, the moment they get a data set, they are jumping into running a logistic regression or a Cox proportion hazards model. Now that should not be the approach. You must always begin with simple things. Begin with simple means, simple median, simple percentages, because I often see that gives the most insights into what you are studying, and then move on to complex regression equations. And I often trust simple means, tables, and proportions to complex regression equations, which often are not very clear. The other approach is be parsimonious in your approach to data analysis, or be judicious. Avoid analyzing everything that is in sight. Okay. Many researchers do this data massaging and try and find out, okay, this intervention does not work in everyone, but in this particular special group who are males, who are blue-eyed, who have a deformity, in them it seems to work. That should not be the approach to analysis. You must decide a priori what is going to be the plan, what is going to be your question, and use analysis only to answer that. No data massaging here to find some p-values. Is that okay? Yeah. The other important principle in data analysis is to pay attention to quality, because there are many points in the process of data analysis where errors can occur. So I've often seen that people make mistakes in data cleaning. Many people do not even do data cleaning. They jump to analysis and then later on realize that there are many problems in the way the data was coded. The second problem is, you must pay utmost attention and care during recoding. And if you make mistakes during recoding, you will end up with entirely different results and different interpretations as a result. So please pay careful attention for recoding, during recoding. The other place where you have to be extremely careful is in your choice of statistics. Depending on the variable, the way you summarize that variable and the test of significance that you use, everything depends on what is the basic kind of variable. So you must be very careful in choosing what statistics for what kind of variables. The other reason we want to emphasize in this course is about balancing theory and practice. Now there are many courses which focuses only on software, or some courses focus only on concepts. Now here we want to have a healthy balance and emphasize both concepts, emphasize interpretation, as well as emphasize how to work with the software to get your results. And as the title says, we want to focus a lot here on efficiency. Now what is being efficient? One of the ways that you can be efficient in analysis is writing a program for analysis. Now most people are after using menu based options. Now that's a great place to begin. I'm not against using menu based options in analysis software, but that is sort of a level of a beginner. You should not get stuck in the kindergarten. You must move ahead and graduate and be able to write a program for analysis. Now, why are we recommending this approach of writing a program for analysis as compared to a menu-based approach? There are three main reasons. One is, whenever you write a program, it leaves a permanent documentation, a clear, transparent documentation of what you have done. And that is very, very useful, for other people to critically look at it, input into it, look at the approach. It's auditable if necessary by others. So that's a good clinical practice in research. The second reason why you want to write a program is it enables repetitive analysis and makes you very, very efficient. Assume you have finished all your analysis, which is often a series of several hundreds of steps. And then you realize that there is some problem in this particular data. And you go back to the original source and correct that data. Now that you have corrected your data set, you have to repeat the whole analysis, all those hundreds and thousands of steps again. And every time you do that, there are possibilities that you commit mistakes. Whereas if you had already written a program, all you have to do is click a button and it runs the whole program for the revised data set. So this is very, very helpful. It enables repetitive analysis and makes you very, very efficient. The third reason why we recommend you to write a program for analysis is it helps greatly in troubleshooting. For example, let's assume that you are doing some analysis and get stuck somewhere and you need help. So, as happens often in these courses, that you contact your mentors. And how will the mentors know where exactly you got stuck? If you have done a menu-based approach, it becomes very hard to explain how did you approach analysis and where you got stuck. But if you had written a program and you simply share that program, the mentor clearly understands what you did and indicate where you did the mistake and also suggest a corrective workaround. So this is very, very useful for troubleshooting. So as a principle of efficient data analysis, we strongly recommend that you learn to write a program for analysis. Doesn't matter which software you will finally choose to use, but approach of writing a program for analysis is always better than just clicking around the menu. Okay, is that point clear? Because this is going to be one of the key principles that we will reinforce throughout the course. Of course, we are using an open access tool here and not any proprietary softwares, because it's free to use, free to distribute and teach. Now, statistics is a world which often evokes extreme reactions, and it is nicely summarized in the first two quotes here. The first one is attributed to Lord Kelvin. He says, science begins when you begin to speak in terms of numbers. If you are not able to speak in terms of numbers, you are not even a scientist. Okay, so this is one extreme view which says that science means only numbers. The second extreme view is, it says there are three kinds of lies, damn lies, and statistics. This is the other extreme view. This is criticizing statistics as a science and statisticians, to a very unfair degree. It says that you can manipulate anything with numbers, and so don't trust it. Okay, so this is the other extreme view. But as always, truth is somewhere in the middle. And I like this balanced quote by Albert Einstein. He says, not everything that can be counted counts, and not everything that counts can be counted. So he's saying that, he is one of our great scientific minds, and he clearly, was a quantitative guy, but here clearly advocating for qualitative methods. There are several situations where you need a mix of both. And often, if you want to answer a research question completely, you need both qualitative as well as quantitative methods. In terms of finding out how much, when, what, quantitative methods are very useful. But the moment you ask the question why, then qualitative methods are very, very useful. So a mix of both methods is what may be required and should be driven purely by the research question you are asking. So in this course, we will focus on both qualitative as well as quantitative approaches. Let me begin with a nice story here. Okay, I don't know who is it real or is it a fake, but it doesn't matter. So let's begin the story. Once upon a time, there were 3 health researchers, maybe who were doing operational research, and 3 statisticians. Okay, and they were going to attend a conference, and they were planning to travel by a train, and they bought tickets before boarding the train. The 3 health researchers, they bought 1 ticket each, like most of us. But the 3 statisticians bought only 1 ticket among the 3 of them. And the researchers were startled. How does it work? They asked statisticians, how does it work? How can you buy just 1 ticket? The statistician said, we will show you how, don't worry. So they were very interested, they were very keen to see how does it work. So all of them boarded the train, the journey began, and you know what happens in a train. The ticket collector comes and wants to check all the tickets. So the ticket collector came, and as soon as he entered the train, these 3 statisticians, they all sneaked themselves into a bathroom. And the system is, if somebody is in the bathroom, the ticket collector comes and knocks the door. Tuck, tuck. And then there is a small slit in which you can pass the ticket and he will verify and leave. So all the 3 statisticians went into the bathroom. As usual, the ticket collector comes, he knocked the door, tuck, tuck. They pass the ticket in the slit, he verifies, gives it back and leaves. And the researchers are impressed the way it worked. You see, now, these are statisticians with 1 ticket, they are able to travel. Now, this is how it happens in routine settings in data analysis. You go to a statistician, he says something, you don't understand what's happening, and then he gives you something and says, wow, it works. You get a p-value. Be done with it. Okay, so this is what happened. The story continues. So now, the health researchers are impressed. So they said, okay, I'm also going to use the same technique. So they go to the conference, finish it, they come back and travel in the same train. So the health researchers are very keen to try this technique. Okay, so they now bought only 1 ticket among the 3 of them. And they saw that statisticians did not buy any ticket this time. And they were again startled. They asked, how does it work? They said, we will show you how it works. So all of them again boarded into the train, and the ticket collector came. As soon as the ticket collector came, the 3 health researchers, they know the technique now, right? So they sneak into a bathroom and tuck, tuck. What they do? They pass the ticket in the slit. Do you know who collected that ticket? It was the statisticians. They took that ticket and entered another bathroom. So when the ticket collector came, actually the health researchers were caught. Again, the point, what's the moral of this story? The moral of this story is nicely summarized in the sentence below that. Statistics is like a lamppost. Either you can lean on it or walk in its light. And what we strongly recommend in this course is walk in its light and don't lean on it. I'm not saying don't consult statisticians, and they're not wrong people. I'm saying consult them, seek their advice, understand it before you use it. So don't depend heavily and rely on whatever they say. You must always seek their advice, but understand completely before you make use of it. So that sort of summarizes the philosophy about analysis in this course. I mean, there's nothing wrong with statistics. It's a tool like any other tool. So like any other tool, it can be used well as abused or misused. So you have to be careful on how you are using statistics. So research, the simplest definition of research, it's investigation into truth of things. There are three main stages in research: study design, conduct, and analysis and writing it up. Though I have put analysis right in the end, but I must alert you here that the plan for analysis should in fact begin at the design stage. And that is something we are going to do in this course. And that's one of your outputs. I want you to develop a plan of analysis including dummy tables and dummy figures. And sometimes analysis is part of study conduct as well. Have you heard of this term called interim analysis? Yes. So, there even in big trials, there is a clear plan for interim analysis. And if you find in interim analysis that an intervention group is doing much better as compared to a control group, then you can actually stop the trial at that point. And there are several examples of this in real life. And then, of course, the bulk of the analysis happens at the end of the study. And in statistics, there are two kinds of statistics. It can be broadly categorized into two types: descriptive statistics and inferential statistics. I'm going to describe this briefly in a moment. As one of the definitions of statistics is a set of methods for organizing, summarizing, and interpreting information. There are two broad types: descriptive statistics and inferential statistics. Now, the purpose of descriptive statistics are to describe the data, to summarize, organize, and simplify data. And there are two major ways of describing the data. In case of continuous variables, I'm sure you've now familiar of the types of variables. We discussed it in the module 1. So in terms of continuous variables, the way we summarize is we give a measure of central tendency and a measure of variation. We will learn all about this in subsequent presentations. Whereas in categorical situations, in categorical variables, you summarize by frequencies, proportions, ratios, and rates. Inferential statistics, what is the goal of inferential statistics? The goal is it allows us to study samples, which most of the time that is what we are doing in research, and then make generalizations about the population from which the samples were drawn. Okay, and there are two important things we have to learn here. One relates to estimation, okay, which is the realm of confidence intervals, and the other relates to hypothesis testing, which is nothing but statistical tests of significance, the chi-square test, the t-test, etc., etc. Is this clear? So this is going to be our focus in the next 2 days. Now let me briefly give you a introduction to the Epidata analysis software. Okay, this is the software which we are going to use. Let me just give a peep into the basic anatomy of the software and introduce you to some shortcuts. And shortcuts or hotkeys are a great way of improving efficiency. Remember, that's one of our running principles throughout the course. The moment you open Epidata analysis, you get a screen like this, and right on top you can see the name of the software, Epidata analysis, and the version. Okay, and if you have opened the file, it will also tell you what is the file which is currently open as well as where it is located. Just below that title bar, you have a menu bar like any other Windows application. And below the menu bar, you have something called as work process toolbar, similar to what we found in Epidata entry. And then there is a big screen here, which is called as the results viewer. Now this is where all the results, all the outputs are seen. Okay, whenever you do some analysis, this is where you find the output. And then there is something called as a command line or a command prompt. Now there are three ways of interacting with the software. Okay, one is through the menu options. You can click around in the menu and get what you want. The second approach is to use the command line or the command prompt. Now here you can type the commands and press an enter key to execute them, and we will go through all of this in a little while. And then below the command prompt you have something called as status bar, akin to what we saw in Epidata entry, and it provides several important information. We will go through the details of all of this. And then there are some windows here on the side. Okay, there are some command window, variable window, history window, etc., etc. Let me show that to you in the next slide, and introduce also to some of the shortcuts. Now these shortcuts are very helpful. As I told you, it increases your efficiency in a great way. F1 is for help. This is the common shortcut, not only in this software but most of the Windows application, so that stays F1. Now F2 is for commands window. This gives a peep into all the commands. So let's assume you want to find out something about tables. Okay, now you can go here and find out the exact command and then search for that command in the help section. That greatly facilitates. Okay, the other window we have is variables window. So whenever you open a data set, if you want to know what are the variables in the data set, then you press F3 and then this window will be visible to you. Okay, and then you have the results viewer. There is a way to clear your screen in case you have done too much analysis, it's all cluttered, want to begin with a clean slate, clear screen. Okay, and in fact the command is not F10, it's F12. F10 is to quit. The command line, if you want to go to the command line from anywhere, then the shortcut is F4. The history window shortcut is F7. This is a document of all that you are doing. It keeps a log of all the analysis, everything that you do in the software. So if you want to go back and see what you have done, then go to history window using F7. There are some other shortcuts if you want to access the editor. So this is the third way of interacting with the software, which is to use an editor. So if you want to use an editor, then press F5 and then you have access to the editor. And within an editor, if you want to run a command, run a selected portion of the program or one line, then you use F8. If you want to run the whole program, then you use F9. Okay, so we will go through each of this. And F6 is the shortcut key to browse your data. So you've read the data and want to browse, press F6 and you can browse it in the form of a spreadsheet. Is this all clear? Don't worry if it's too overwhelming to see all the shortcuts at once. As we start to learn one by one, it becomes very, very easy. And with practice, it becomes your second nature. Is that okay? Thank you very much.